As I said earlier, we're going to discuss about discrete and continuous and variable. So we will look into that, the binomial and as well as the Poissons for the under the discrete probability distribution and the continuous probability distribution, and as which is normal and uniform exponential will be covered in the upcoming classes. All right. Now today we're going to focus on these two methods. All right. Now, take a look at the binomial probability distribution. Binomial, all right, it's very simple. There is a unique way you need to identify whether the experiment is represent the binomial or Poisson. All right. First thing is N. The N is identical trial. Okay, we call it N is a identical trial. And each trial has a two possible outcomes. All right. Each trial has a two possible outcome. One is success, another is failure. Okay. And then the success, usually they indicate as the P is the same for that each outcome. So means it's constants. Okay. The probability of the success is always the same for each outcomes. And the last one, the trials are independent. All right. We call it independent. It's not, and which means that the observation doesn't affect that outcome of the other. Okay. So this is that the property of the binomial experiment. Okay, so just need to understand the four binomial condition, the binomial distribution condition. Okay, moving on. All right, now we're going to look into the number of successes occurring in the N trials. This is what we're going to focus on in the binomial expression. And we let the X denote the number of successes occurring in that N trials. Okay, now, all right, for example, you can see some how you're going to differentiate that the binomial, all right, in terms of the success and failure. So usually there is a two outcomes. One is, okay, the defective or acceptable. All right, for example, in the manufacturing plant, labels items either defective and acceptable. So these two options, so P or Q. All right, so P is a success, Q is a failure. All right, so you need to understand that. All right. All right, now take a look. The marketing research firms receive the survey response of that. Yes, I will buy, or not, I will buy. So it means either one of these options can be success and another one is a failure. Okay, so you can see. So our other example, okay, so new job applicant, whether it's accept or reject, okay, and so on. All right, so this is how you're going to identify or differentiate, all right, the binomial experiment. Okay, so in this sense, we have to know the rule of combination. All right, the combination theory, I'm sure you all studied before. All right, so combination, okay, is a selecting X object out of the N object. So we can represent in the form of the formula. So usually it also can be represent, all right, so N is supposed to be N combination X, which is represents, okay, so N factorial over X factorial in bracket N minus X factorial. So this is a formula you need to remember in order to choose that how many combination can be formed. Okay, so this is that the determination for each every one of it. I'm sure you all know about it. Okay, you have learned that before. All right, now say you're going to develop that binomial distribution formula. Okay, Px equal to X, all right, which is given N combination X multiplied by the probability of success power of X multiplied by 1 minus P. So 1 minus P also, okay, we can express this form 1 minus probability of success. So it represent that the probability of failure. Okay, it also can be written in this way. All right, so 1 minus P power N minus X. Or the other forms, we also can be written the above formula as this. Okay. All right, so this is that the explanation for each every variables which is given in the formulas. All right, for example, a firm bought 10 computers. Okay, the N is equal to 10. All right, and if the probability of the purchasing defective computer is given is 0.08, And what is the probability of purchasing two defective computers? So you can choose either this is P or Q, all right? So we just stick with that one, right? So say, for example, we have two defective computers. So X is represent the X, so X equal to 2, and N is 10, and the defective, all right, it's 0.08. So you just initiate as a P equal to 0.08. So now you use a formula, all right, 10 combination 2, because out of 10 computers, you choose 2 computers are defective. So the defective probability is a 0.08 power of 2. So X is a represent for the X value. And then the failure, all right, so defective means, all right, the complementary of this defective is 1 minus 0.08. So power of 10 minus 2 is a formula up there. So you get a 0.1478. So which means probability of purchasing two defective computer is about 14% or 14.78%. Okay, so this is how you need to explain. Okay. All right, now another example. What's the probability of the one success in 5 observation if the probability of the success is 0.1? Right. So as we know that the one success in 5 observation, all right. So we have the random variable is x1. So we have the total observation is 5, and the probability of success is 0.1. So you just write in there, and then use a formula, all right. When x equal to 1, so use the formulas, the one I just showed to you, substitute everything. So then we get a 0.32805. So which means the probability of one success in 5 observation is about 32.8%. Okay, so that is your interpretation. Okay, now this is an example. All right, I just want you to do as an exercise. Okay, do as an exercise. So I think I give you the working step as well for this. Okay, so this is a homework. All right, now for the binomial distribution, so we know that the expected mean, all right, we calculate with that NP. So number of the trials multiplied by that, the P value, the probability value. Okay, so the probability of success. All right, so then we can get the expected mean. Okay, so the expected mean we can easily calculate. Okay, by multiplying the number of trial with that the probability of the success. So that's what we call is a mean is equal to NP. All right. Again, the variance and standard deviation is very simple. So we use this formula. So is variance equal to NP. So number of trial multiplied by the probability of success multiplied by 1 minus P. Or other words, you also can be written as this form, NPQ. All right. So Q is a probability of success. Okay. As you know, the Q is equal to 1 minus P. Okay. All right. So this is the standard deviation. All right. Standard deviation, square root of the variance, standard deviation. Or this is the abbreviation for every one of it. Okay. Even is concerned about a low retention rate for employees. In recent years, management has seen a turnover of 10% of the hourly employees annually. Okay, so which means they said the turnovers of 10% of the hourly employee annually. Thus, for any hourly employee chosen at random, management estimate a probability of 0.1 that person will not be with the company next year. That means they will send off. Okay, they send off the probability of 0.1, around 0.1, they estimated. Okay. Now, the first question, choosing 3 hourly employee at random, and what is that the probability that one of them will leave the company this year? All right. Now, second question, they wanted to compute that the mean and the standard deviation. All right. These are 2 things you need to understand very clearly. All right. So say if you choose choosing a 3 hourly employee at random, okay, so we choose 3 employees, and what is the probability that one of them will be potential to be leave this company? All right, and then we need to know that what is the mean and the standard deviation. All right, so now First of all, what all you need to do, okay, you need to list down all the information that we have. So we have the company retention. We have around 10%, so 0.1. And then we choose 3 people, okay? So, and we choose one is leave the company for this year. So now this is development information as we know, and we're going to count the probability those who will leave the company. All right. So as you know that the formula we written right now. So just now, so n factorial over x in factorial in bracket n minus x, okay, and close bracket factorial, and then this is stand for the nc x, okay, and then the probability of we have 0.1, so p power of x minus multiplied by 1 minus p n minus x. So this is all the information, so already know. All right, we have it. So just plug into it according to it. Okay, so n, we have a 3, n is 3, so plug here 3 factorial over. So, and the probability, the x value, which is 1 factorial, and the number of people or employees is 3, so 3 minus 1, so factorial. So the probability of success, the p-value is 10%, so 0.1 power of 1 multiplied by 1 minus 0.1, and this n minus x, so it means you get a 3 minus 1. So you simplify, you get a 0.243. So which means you can conclude that there is a 24% or 24.3% chances that 1% will leave the company this year. So that's how you need to calculate. All right. Further, you're going to compute that the mean and standard deviation. It's very simple. So as we know that expected mean value, all right. So expected mean is n multiplied by p, and we know that the number of people we're choosing is 3. So multiplied by the 10% turnover is 0.1. So we can say that it's 0.3 employees out of 3. Okay, so this is the mean value, expected mean values. Okay, and then the variance, again, so use the formula. So variance is equal to NP multiplied by in bracket 1 minus P, so which is equivalent to 3, and the probability is a 0.1 multiplied by 0.9, and you get a 0.27. Okay, you look for the standard deviation, just square root of the variance, then you can get a 0.52 employees. Okay, so these are the turnovers chances they will leave the company. All right.